Hey everyone, welcome to Insights by Rish. Today we are going to implement a classification project of machine learning of heart failure prediction, and for that we have this particular dataset from Kaggle which consists of 13 columns, and these are all the columns present. This is the information about the dataset. You have age of the patient, the decrease of red blood cells or hemoglobin. You have the information about whether the person had diabetes or not, the gender of the woman, and all this data set, and you have your target feature at the end, which is the death event. You want to classify whether the person died during the follow-up or whether they survived. So depending upon all these attributes, you want to classify whether the person died due to heart failure or not. So we'll start building the project. Initially we will import all the necessary libraries that we require, so let us name this as libraries. So first we will import pandas as PD. Then we will also require matplotlib to make any visualizations. So import matplotlib.pyplot as plt. We will also require cbun. And then, as this is a classification project, we will also require the accuracy score, the confusion matrix, and the classification report. So from sklearn.metrics, you will import the accuracy score, the classification report, and the confusion matrix. Now we will also require cross-validation score to evaluate that which classification algorithm of machine learning would be appropriate to use here. So from sklearn.model selection, you will import cross-validation score. And also we will require grid search CV in case if you want to evaluate for the appropriate hyperparameters. So from sklearn.model selection, you will import grid search CV. Let's run this. Now we will load our dataset. So we will load our dataset into a variable df. So pd.readcsv, and I will provide the path on which the dataset is downloaded. Let us try to display the first 5 rows. Let us try to display the first 5 rows of the dataset. So this is our dataset. It consists of all the columns, and I think we don't have any unwanted column here. Also, we don't have any categorical column here. So the only thing that we want to pre-process is all these numerical values. Now, let us check for missing values if in case this dataset consists of any null values. So we'll say df dot. So we are checking here for null values. So we will say df dot isInA dot sum. As you can see, every value is 0, which means this dataset doesn't consist any null value. The next thing that we want to do here now, we want to perform scaling. So first we will divide our dataset into the input feature and target feature. So let us name this dividing the data into input and target feature. So we'll say x is a data frame into which we will store all our input features. So x is equal to df.drop columns is equal to, we want to drop the death event column, which would be our target feature, and apart from this death event column, we want to include all other columns in our input feature data frame. So we'll say death event. And the next thing, we will create a y variable into which we will store our target values. So df. Let us try to display the input data frame. And you can see now it consists of all the columns except for the death event column. And if you try to display the y, you will see it consists of all the Boolean outputs. So The next thing that we want to do here is, now that we have divided our data set into the input and target feature, we will perform data normalization. So we will perform data normalization. So to perform data normalization, there are various techniques, but we are going to use the min-max scaler, which basically scales all your data between the values 0 and 1. So from sklearn dot preprocessing, we will import min-max scaler, and we will create an object of scaler, which will be scaler min-max scaler, and we will create data frame with same name x, and we will store all the transformed values here. We are performing the fit transform method, which will do both the things of fitting and transforming in one single go. So we will say scaler dot fit underscore transform x. These are all the warnings. If you don't want these warnings, if you want to ignore that, you can just include a module here. So we'll say import warnings. We'll say warnings dot filter warnings ignore. And now when you rerun this particular cell, you won't get any warnings. Let us try to display the first 5 rows of the input data frame, and now you can see all the data is scaled between 0 and 1. And the next thing that we will do here is we will divide this data set into the training and testing set. So from sklearn dot model selection, you will import train test split, and you will say xtrain, xtest, ytrain, and ytest, and you will say train test split. Here you will pass your input data frame, which is x, and the target data frame, which is y, and test size is equal to 0.2, which means 80% data in the training set and 20% data in the testing set, and random state is equal to 42. Let's run this, and let us check how many instances are now included in the training and the testing set. Xtest.shape. So out of 5,000 rows, now 40,000 rows are in the training set and 10,000 rows are in the testing set. Now we want to choose an appropriate classification algorithm in order to build our model. So you can randomly go for any algorithm that you want to implement, or you can perform the cross validation on this particular data set in order to evaluate which model, which algorithm would be appropriate. To do so, we have already imported the cross validation score from model selection here. We'll write a function here. So we'll write def k-fold, which will take estimator. Estimator is basically the algorithm that you want to evaluate upon, then the input, and then the target, and you will return the cross validation score for estimator. Actually it's estimator, then input, and then target. Now what all algorithms you want here in order to evaluate upon that, let us import all those. So we'll say from sklearn dot linear model, you will import logistic regression, then from sklearn dot svm, you will import svc, which is the simple vector classifier, and from sklearn dot ensemble, you will import random forest classifier. Let's run this, and let's also run this function. Now we will evaluate our data set firstly on using the logistic regression model. So we will pass logistic regression here, and the input is xtrain and the target is ytrain. Let's run this, and as you can see, you are getting an array of values because this particular cross validation score performs the 5 folds. In a first fold, it will extract some n features, n instances, and evaluate upon that. In the next fold, it will extract another n features and will evaluate a model upon that, and it will give you an accuracy for all those folds. Now you want the mean average accuracy, so we'll say mean. Also you want your accuracy in the percentage, and hence you will multiply it by 100. So when you are using logistic regression algorithm for classification, you will get 85% accuracy. Let's do the same thing using support vector classifier. So SVC. When you prefer support vector classifier here, you are getting an accuracy of 89%. And let us also evaluate using the random forest classifier. So you are getting the highest accuracy when you are using random forest classifier. You can compare, there's a drastic difference between the logistic regression and the random forest classifier here. So we will go ahead with random forest classifier. Now the next thing that we'll do here, we'll start building our model. But random forest classifier has some parameters, has some hyperparameters, and as you change the values of those hyperparameters, your accuracy also fluctuates. So in order to choose the best, or you can say the appropriate hyperparameter, you need to implement a technique called as grid search CV. I've already imported here the module from model selection. Now we'll use that before building our model. We want to evaluate our model for different hyperparameters and choose the best appropriate hyperparameters that will increase our accuracy. So we'll say classifier is equal to grid search CV, and here I will pass the algorithm for which I am going to evaluate the hyperparameters, which is random forest classifier. And then I will say the first hyperparameter that you have in your random forest classifier is the n estimator. If you want, you can just go on Google and check for random forest classifier by scikit-learn, the official documentation, and you will get this particular page. So you have all these hyperparameters. So we'll start with n estimators. So the number of estimators you want, that is basically the number of trees that you are going to build into your random forest, the number of decision trees. So the first is n estimators. Let us paste it. Now you can give any number of values that you want here, that you want to evaluate upon. So let's say first I will say my n estimators to be 50. The 100 is the default value, then 100, and then 150. I am going to evaluate my random forest classifier onto this 3 n estimators. Then the maximum depth of tree that you want, how many levels you want in your decision tree. So you can say max depth. My max depth can be 3, or you can say 3, 5, and 7. The next hyperparameter that you have here is the minimum sample leaves, and all those you don't require. You just require n estimators, maximum depth, and min sample split. That how many you want to split your node into how many further nodes. So minimum split value starts from 2. So we'll just say minimum sample split 2, 3, and 4. And then we will fit this classifier onto our X train and Y train. X train and Y train. Now that we have performed the grid search CV, next we will create a data frame out of this. So we'll say classifier df is equal to pd.dataframe, and here we'll say classifier dot something called cv underscore results underscore this. Let's run this, and now we will check the columns from the classifier df. So classifier df dot columns. So we have all these columns, and we just want to check the columns of our hyperparameters and the test score. So we'll just try to display the required columns. Classifier df, first column that we want to display is for n estimators. So maximum depth, minimum sample split, and n estimators. This, and after that the mean test score. Now you also want the highest accuracy to be displayed on the top. So we'll sort it up depending upon based upon mean test score. So sort values by mean test score, and ascending is equal to false. Let's run this. This is what you get. you can see the highest accuracy that you are getting is when you use the max depth as 7, the minimum sample split as 2, and the n estimators as 150. So you will use all these hyperparameters that will basically give you the highest accuracy. So let us build our model, and the first parameter you will give is n jobs is equal to 1, which will allow you for parallel processing, and then the n estimators. N estimators, according to this particular classifier, the best n estimator value is 150. Then the max depth would be 7, and the minimum sample split is 2. So let us say model dot fit our x train and y train. Now that we have built our model, we will do some predictions here first. So let us display the true labels from the testing set. So the first 5 true labels are 0, 1, 1, 0. 0 means the person survived and 1 means the person died due to heart failure. So in this first true labels, you can see the person mentioned in the first row and the 5th row survived, while all other persons died. Let us check what our model has predicted. So we'll say model dot predict for x test, and we'll store this value into a variable called pred, and we'll try to display the first 5 predicted values. So you can see in the true labels you have 2 people survived. In your true labels 2 people survived, while in your predicted values 3 people survived. And let us try to check the accuracy score here. What's the accuracy of your model? So we'll supply the first true labels which are stored in y-test and the predicted values which are stored in the pred variable, and we'll multiply it by 100. So the accuracy of our model is 97%. That is, the model is giving an accuracy of 97%. Next, we'll also try to print the classification report if you want to check whether the dataset is balanced or imbalanced. We'll say classification report. We'll supply the true label and the predicted one. As you can see, the F1 score for both the categories, that is 0 and 1, are good, and there is not a drastic difference between both of that. Hence, we can say the dataset is balanced. Also, the precision for both the categories is good. Now that we have printed our classification report, the last thing that we want to do here is we will print our confusion matrix using the Seaborn library. I think we haven't imported Seaborn here. So we want to say import Seaborn as SNS. SNS.heatmap. We first need to build a confusion matrix here. So we'll say confusion matrix is equal to, we'll provide the true labels which are stored in y-test and the predicted labels which are stored in pred. Then we'll say normalize is equal to true. And then we'll pass this confusion matrix variable, which is CF here. We'll say anot is equal to true, where we want to display the values on the grid. And we'll say CMap is equal to crest, which is the theme of the heat map. You can mention any color that you want. So this is the confusion matrix that we have got. And if you want, we can label it. So we'll say plt.xlabel. On the x-axis, you have predicted values, and plt.ylabel. On the y-axis, you have actual values. As you can see, if you check the diagonals, on the diagonals you have the accuracy for correct classification. So 99% times the person survived, and your model has also predicted that the person has survived. While just 1% time, it's happening that actually the person survived, but the model is predicting that the person died. While 94% times the person died due to heart failure, and the model also predicts the same, while only 6% times there's a misclassification. So this is the confusion matrix, and the model is giving an accuracy of 97%. So that's it for the video. Thanks for watching.